Okay, picture this. It's Friday night, you're on your couch, you've had a long week, and you're just, mindlessly scrolling through your favorite app.
Or trying to order a pizza, maybe.
Yeah, exactly. And suddenly the screen freezes. The app just crashes, closes itself. What's your reaction?
Frustration. Maybe a sigh. I probably force close it, reopen it, and honestly, within 30 seconds, I've completely forgotten it even happened.
Exactly. You just roll your eyes and move on. The stakes are incredibly low. The worst case scenario is your pepperoni pizza shows up 10 minutes late.
It's an inconvenience, that's it.
Right. But now let's transport you. You're no longer on your couch. You are 30,000 feet in the air in a massive commercial airliner. And the software that decides to freeze isn't a food delivery app.
No.
It's the flight control system, the thing handling, I don't know, the landing gear or the autopilot. And suddenly that famous Silicon Valley motto, move fast and break things.
Doesn't sound so cute anymore, does it?
It really doesn't. In fact, if you walked into a meeting at Boeing or Airbus and pitched that as your new strategy,
Security would probably escort you out of the building.
yeah. And that is exactly the tension we're exploring today. It's this collision between two completely different philosophies. On one side, you have the modern tech world, which is obsessed with agile,
Yeah.
speed, flexibility, constant updates.
Pushing code to production 5 times a day.
And on the other side, you have the aerospace industry, which historically
I
is,
know, right.
well, let's be charitable and call it deliberate.
Deliberate. That's a very polite way of saying slow.
Very slow.
It is slow.
Yeah.
But for a good reason. It's rigid because, when lives are on the line, you can't just release a beta version of a plane and wait for user feedback.
Precisely. So the mission for this deep dive, and this is all based on a really comprehensive paper called Weaving Agility in Safety-Critical Software Development for Aerospace, is to answer a huge question.
Right.
Can we actually bring that agile speed into a world that is legally and ethically required to be safe? Or are we just trying to mix oil and water here?
It's such a fascinating puzzle because we all look at companies like, Google or Amazon pushing updates constantly. And then we look at aviation and think, why does it take 10 years to build a new plane?
Yeah. What's the holdup?
And we assume the answer is just safety takes time. But the source material suggests it's way more complicated. It's not just about time. It's about the process and the evidence.
And speaking of process, we have to start with the rule book. In the source material, everything seems to orbit around this one document with a very catchy name, DO-178C.
Ah, yes, the Bible of avionics software.
Sounds like a droid from Star Wars. DO-178C, bring me the Hydra spanner. What? What is this thing?
So DO-178C, or Software Considerations in Airborne Systems and Equipment Certification, is the global standard, whether you're dealing with the FAA in the U.S. or
EASA in Europe.
EASA in Europe, exactly.
Yeah.
If you want to put code on a flying machine, that code has to pass the DO-178C exam.
Okay, so this is the checklist, the instructions.
Well, see, here's the common misconception, and it's a big one. People think this document tells you how to write code.
It doesn't. I kind of assumed it was like a strict set of instructions.
Not at all. It doesn't care if you use C++, I, or Ada, or Python. It just creates a framework for evidence. It tells you if you want your software certified, you must prove with a mountain of evidence that it does exactly what it's supposed to do.
And probably that it doesn't do anything else.
Exactly. And proving that it doesn't do what it's not supposed to do is actually the harder part.
So it's less of a recipe book and more of a final exam?
That is a great analogy. It's a final exam where you have to show your work for every single answer. And the difficulty of that exam depends entirely on how dangerous the software is. This is where we get into the safety pyramid, or DL design assurance levels.
I saw this in the notes. It goes from level A down to level E. Walk us through the stakes here, because this really dictates everything.
Okay, so at the very, very top of the pyramid, you have level A. This is labeled catastrophic.
Catastrophic. Yeah, that's not a word you want associated with your flight.
No. If software at level A fails, the plane crashes.
Yeah.
People die. We're talking about fly-by-wire flight controls, engine control systems, the big stuff.
So the scrutiny is absolute.
It's absolute. You have to prove traceability for every single line of code.
What does traceability really mean in this context?
It means you need a chain of custody. You need to be able to point to a line of code and say, this line exists to satisfy requirement X, and here is test case Y that proves this line works.
And if it doesn't?
If you have a line of code that doesn't link back to a requirement, you have to delete it. No ghost code allowed.
Wow. Okay, that is intense. What's the next step down?
Level B is hazardous. A failure here might cause, say, a serious injury or a massive reduction in safety margins, but the crew could technically still handle it.
So like a fuel display giving bad data?
Perfect example. It's bad, it's extremely stressful for the pilots, but it's survivable if they're well trained.
So level A is the computer killed us, and level B is the computer tried to kill us, but we saved it.
Essentially, yes. Then you get level C, which is major. This might cause passenger discomfort or increase the crew's workload. Maybe a communication radio fails, but you have a backup.
And level D is minor, like the cabin lighting system acting up.
Right. And then finally, level E is no effect. This is the in-flight entertainment system.
The movie player.
The movie player. If it freezes, it's annoying, you might have a grumpy passenger, but the plane flies just fine. Level E is actually the only level where you don't really need to do all this rigorous verification.
So if I'm writing code for the movie player, I can be as agile as I want, move fast, and break the rom-com.
Pretty much.
Yeah.
But the second you touch anything that affects the safety of that flight even remotely, you enter the world of DO-178C. And this is where the conflict starts.
Okay.
The source highlights this staggering statistic. In the general software world, apps, websites, whatever, about 80% of companies use agile methodologies.
Right. It's the industry standard. If you aren't doing agile in tech, you're a dinosaur.
Exactly. But if you look at safety-critical industries, aerospace, healthcare, energy, that number just drops off a cliff. It's about 19%.
That is a massive gap, 80% versus 19%. Why is it just fear?
Fear is a huge part of it. There's this deep-seated belief in the aerospace industry that agile is cowboy coding.
Cowboy coding.
You know, shooting from the hip. They think agile means no documentation, no planning, just making it up as you go. And when your rule book, DO-178C, demands perfect documentation, agile just feels like a risk you can't take.
So they stick to what they know, the traditional waterfall method.
They stick to waterfall because it feels safer. It's linear, right? You do all the requirements first, then all the design, then all the coding. Then only at the very end do you test it.
It flows down like a waterfall. You can't go back up.
Right. And the problem is, if you find a mistake at the bottom after 2 years of work, it's a nightmare. It's unbelievably expensive to fix.
But it produces a lot of paper at every stage, so it looks compliant.
It looks compliant. But the paper we're deep diving into today says this whole fear is misplaced. It calls it the myth of incompatibility.
Okay, so this is the big reveal.
This is the aha moment. DO-178C does not require you to use waterfall. It is method agnostic.
It doesn't care about the journey, only the destination.
Exactly. It wants the evidence. It doesn't care how you generated it. You could take a Ferrari or a horse and buggy. As long as you arrive with the right paperwork, the certification authorities are happy.
So if it's allowed, why isn't everyone doing it? Why are we stuck at 19%?
Because even if it's legally allowed, it's functionally very difficult. There are real friction points. The first one is documentation. The Agile Manifesto famously says working software over comprehensive documentation.
Which sounds great until the FAA inspector walks in the door.
Right. DO-170C says, I don't care if the software works, show me the paper that proves it works. So an agile team in aerospace has to be fast while still generating, mountains of paperwork. It feels like a contradiction.
Okay, what else?
Then you have hardware dependencies. In a normal tech startup, you code and you test. In aerospace, the computer you're writing code for might not even be built yet. You can't sprint through a landing gear test if the landing gear doesn't exist.
So you're just waiting around.
You're waiting on the nuts and bolts, guys. And finally, there's just cultural resistance. The source notes that established habits are a huge blocker. Imagine you spent 30 years doing waterfall. It's worked. Now some consultant comes in and tells you to do daily stand-ups.
Yeah, if it ain't broke, don't fix it. Even if not broke means it takes 5 years to update one system.
Exactly.
But the paper does offer proof that this can work. It's not just theory. They looked at some heavy hitters, like Airbus. What did they find?
This was a fascinating case study. Airbus didn't just blindly switch. They experimented. They tried an incremental approach, a functional one, and a fully agile one. And the most successful tactic they found in the agile model was something called micro-reviews.
Micro-reviews, so smaller reviews.
Tiny ones. In the old waterfall world, you might wait until the very end for one massive critical design review. It's this huge event with hundreds of documents.
It sounds like defending a PhD thesis, but for an airplane?
It is. And it's super risky. With micro-reviews, Airbus broke features into tiny chunks. They reviewed the requirements, the code, and the tests for just one small function as they built it.
So instead of a 1,000-page exam at the end of the year, it's like a quiz every Friday.
Exactly. And it's just easier for the human brain. It's much easier to verify, does this one button work, than does this entire cockpit system work. You catch a mistake in week 2, not year 2.
That seems like it would actually be safer in the long run.
That's the argument.
Yeah.
And the data backs it up. The source also talks about an experiment with a UAV and unmanned aerial vehicle. They had teams develop a cockpit display system. Some used waterfall, others used agile scrum.
And who won?
The agile teams. But here's the kicker. They didn't just code faster. They actually produced higher quality artifacts. Their documentation was better.
Wait, really? The agile teams had better documentation. That goes against every stereotype about developers I've ever heard.
It does, but it makes sense if you think about it. Because they were iterating constantly, they were updating and checking their work while it was fresh in their minds. The waterfall team saved all the paperwork for the end.
And when you rush documentation at the end, you get sloppy. You forget why you wrote that line of code 6 months ago.
Exactly. This just debunked that whole idea that agile is sloppy. It showed that agile, done with discipline, is actually more rigorous because it's continuous.
That's a huge insight. The paper also mentioned something called Q-Scrum. Is that like a James Bond gadget?
I wish. No, it stands for Quality Scrum. It's from researchers in Brazil. They realized you can't just take generic Scrum, which is for building websites, and use it for planes, so they modified it. They redefined the definition of done. In normal software, done might mean it works on my laptop. In Q-Scrum, done means the code works, it passes tests, the safety analysis is updated, and the traceability links are documented.
So you literally cannot finish a sprint until the safety paperwork is done.
Exactly. It forces the safety culture into the daily habit. It proves you can hybridize these models and get the best of both worlds.
So we know it's possible. We know it can even be better, but there's still that massive hurdle, the paperwork. Even in small chunks, it's a mountain of evidence. You mentioned every line of code needs to be traced. That sounds exhausting.
It is exhausting. And frankly, humans are terrible at it.
Yeah.
We are just bad at staring at spreadsheets for 10 hours a day. We get tired. We make typos.
I would definitely make typos.
We all would.
Oh.
Which leads us to what the paper calls the game changer. It's a concept called Cert DevOps.
Cert DevOps, certification plus DevOps. Break that down for us.
So DevOps is a standard practice in tech automating testing and deployment. Cert DevOps takes that and applies it to the certification evidence itself.
You mean automating the paperwork?
Exactly. Instead of an engineer manually writing a document that says, yep, test case A passed, you build a system where the computer runs the test, verifies the result, and generates the PDF document automatically.
That sounds like a dream.
The source material cites some preliminary findings that are just mind-blowing. This automation could reduce certification-related documentation work by 50%.
50%? That is massive. That's cutting the boring part of the job in half.
And it improves quality. The automation addressed over 75% of common defects that usually become problem reports.
Which are basically the bug tickets of the aerospace world.
Right. In a manual process, you might mistype a test result or forget to update a version number. A script doesn't make those mistakes. You free up the engineers to actually think about safety, not formatting Word documents.
And the paper suggests this could shift the whole paradigm of how audits work. This part really blew my mind.
Yes. This is the futuristic part. Right now, the FAA comes in and audits the pile of paper you produced. In a certain DevOps world, they might stop auditing the paper and start auditing the automation infrastructure itself.
So instead of checking the cookies, they inspect the cookie factory.
Exactly. If they trust the robot that writes the report, they don't need to read every single page. They certify the tool, and the tool certifies the code.
That's wildly more efficient. But I imagine setting that up requires a lot of resources. What about the little guys? You know, we're seeing all these startups now flying taxis, delivery drones. They don't have the budget of a Boeing.
That is a critical point. The startup environment is fast and cash-strapped. They can't spend 3 years building a massive Cert DevOps pipeline before they fly their first prototype. They'll just go bankrupt.
So what do? Ignore safety.
No, that's not an option. The source suggests for these players, it's about tailoring.
Tailoring. That sounds like a nice way of saying cutting corners.
It's actually more about focus. You don't skip safety, you prioritize your effort. The paper suggests using a custom workflow based on a subset of the DO 178C objectives. You focus on the really high-value ones first, the ones that keep the prototype from falling out of the sky.
So you're building the foundation correctly, even if you aren't building the whole house yet.
Exactly.
Yeah.
You organize your data so that when you do go for full certification later, you don't have to start from scratch. So many startups make the mistake of just getting it flying with messy code, and then they realize they have to rewrite everything. Tailoring prevents that.
That's just smart. And it seems like even the military is moving this way. I always think of them as having their own separate rule book.
They used to. But the source mentions that even military-embedded software is shifting away from unique military standards and adopting civil ones like DO 178C.
Why the change of heart?
They want that commercial quality and efficiency. They see the commercial sectors innovating faster, and they want to leverage those same tools. They don't want to be stuck with expensive proprietary systems.
So it really feels like everyone is converging on this. The big players, the startups, the military, the whole narrative of agile versus safety is, well, it's dead.
It should be. In fact, the argument here is that they need each other. The complexity of modern aircraft is skyrocketing. You have millions of lines of code in a jet now. You simply cannot manage that complexity with a manual waterfall process anymore.
It's too slow and too hard for humans to keep in their heads.
Exactly. So Agile provides the mechanism to handle the complexity.
And DO 178C provides the guardrails to keep it safe.
That's the perfect way to put it.
You know, I started this thinking, why can't planes be updated like my phone? And the answer is, they can if we build the right robots to check the work.
That's the key takeaway. It's not about choosing between safe and fast. It's about using tools like automation and hybrid models, like that Q Scrum, to get both. The future isn't slow. It's fast, automated, and rigorously verified.
So for you listening, even if you aren't building an airplane, there's a lesson here. We often think of regulations as just red tape, but this shows they're really just constraints, and you can innovate inside those constraints.
Absolutely. Innovation often happens because of constraints, not in the absence of them.
Before we wrap up, I have a thought that's been nagging me. We talked about automating the paperwork cert DevOps, we talked about automating testing, but now we're seeing the rise of AI in coding itself. Tools like GitHub Copilot are writing code right now.
Uh-oh. I see where you're going with this.
If we can automate the safety paperwork for an airplane, what happens when an AI starts writing the safety-critical code itself? We have regulations like DO 178C to check human code, but can our regulations keep up with AI-generated code that might change every second?
That is the million-dollar question. Actually, it's probably a billion-dollar question. If an AI writes the code and another AI checks it, and a third AI generates the documents, do we trust that loop?
DO 178C is based on determinism, right? Knowing exactly what will happen.
Exactly. If input A happens, output B must happen. AI, by its very nature, can be non-deterministic. It's probabilistic. It makes a best guess. Fitting a probabilistic brain into a deterministic safety box, that is a regulatory headache that I think is going to define the next 20 years of aerospace.
A headache for the regulators, but a fascinating topic for another deep dive. We'll leave you with that thought to mull over on your next flight. Hopefully, the software on that plane was verified with a nice, rigorous checklist.
Whether it was done by a human or a robot, let's hope so.
Thanks for listening to this deep dive. We'll catch you on the next one.